Good afternoon, everybody. Everybody here? Good? Had one? Perfect. Scale is, of course, proud to welcome back Kyle Rankin. Kyle's going to give us a talk today on the free software policy with semi-firm firmware.
All right, yeah, thank you. All right, yeah, thank you everybody for coming to a talk on policy. I mean, it's a good thing it wasn't like right in the morning, you know, or anything where everyone has lunch and it's had an extra hour or two for that to digest a little bit, although it is like tea time, so if you haven't had tea, no, hopefully it won't be too dull. But we do have to do some housekeeping first before I start the talk. The fire marshal has informed me that there's no leaving of Coca-Cola cans next to the projector. So if you have any unopened cans of soda, do not put them next to the exhaust vent. If you're unaware of what I'm talking about, like the last, yeah, so that doesn't go there. Yeah, if it's open, you can totally, if you like warm, flat soda, you can totally leave an open can there, but definitely no closed can. So last scale, we didn't follow that fire marshal guidance, and about, I don't know, maybe about 3/4 of the way through the talk, it sounded like a gun went off in the middle of the talk, and everyone jumps. And I jumped, but I could see, like a lot of people, just the way that the room was organized, you couldn't see what happened. Like I could see, because I was up on stage, I could see like this liquid just sort of shooting up straight in the air, right? And then after everyone sort of calms down, and I'm sitting here thinking, man, I have this great opportunity to come up with like a joke, you know, because like, okay, come on, brain, you can do this, you can do it. And the brain just wasn't doing it. It was too shocked. Like I couldn't come up with anything funny. And then I remember, so then I like, okay, fine, sorry, and I explained, like, I was gonna do something funny, I can't. Then I go to the next slide, and it was something like surprises, I forget, like something about something can be explosion. It actually was referencing like, surprises can happen at any time. Yeah, surprises can happen at any time, or something like the next slide was just like cute, set up the perfect thing, and then, yeah, it was great. So this, I can't promise any explosions. In fact, we're gonna try to reduce those in this talk, so hopefully it's just explosive content, right? All right. So, yeah, I know. So, in any case, so my name's Kyle Rankin. I am the president of Purism. We make hardware that runs a lot of free software. We also sell services. We make things like laptops and phones and things like that. In addition to that, in the past, I wrote for Linux Journal for a long time, and I've written a number of books on Linux and security and things like that. But this talk is all about firmware. So, sort of a semi-introduction. I should probably start by saying I am no firmware expert. All right, so if you're coming here looking for firmware expertise, I ain't it. I do, at best, I'm kind of a semi-developer for firmware, and what I mean by that is, so part of the projects I work on, one of them is called Pure Boot, which is a payload that runs within Core Boot that allows us to do sort of like a security tamper detection. It's based on this project called Heads, and so I've done quite a bit of development on that, but to be honest, most of that runtime is written in Bash, if you could believe it. So yes, I'm developing firmware, but I'm actually writing it in the form of Bash scripts, because old school sysadmin stuff, habits die hard. But anyway, so that's like the background. So if you are a firmware expert, then let me preemptively bow to your expertise. There's no need to prove that you know more than me about firmware. It's already acknowledged. So that's all of those well actuallys are out of the way. So we can move on. But actually, it doesn't really matter whether I'm expert, because this is not a technical talk. All right. So this is actually a policy talk. So while we will be discussing some technical details of firmware, you don't need to know much about firmware to get stuff out of this talk. We're going to be more talking about how firmware policy has some of the issues with it, basically, that I've run into. So a lot of things I'm not. One thing I do is I do make hardware that runs free software with open firmware in it. So I do have a background in that and what it is like to try to make hardware that is as open and free as possible. And so that's sort of the background that I'm coming to this from. So that's my level of experience with this, is explaining what is it like when you have big goals to have free open hardware, that sort of thing. What do you run into in the real world trying to implement that? It's very challenging to make everything free. There's a lot of things in particular in hardware and firmware that make it difficult, and that's what we'll be talking about. But also, especially if you're looking into open hardware, if you're building open hardware, a lot of what makes that open is the free firmware that is underpinning it. So you need to have free firmware to have open hardware in many ways. And this is sort of a crux of the talk, I guess, is that currently there's not a whole lot of policy documents or guidance if you wanted to say, I want to have firmware that is free in particular, or hardware that is free. There's limited guidance if you're someone like me who wants to build this and do it the right way. There is guidance out there, but it's very limited, and unfortunately some of it was established. It's somewhat out of date, I guess. The way that firmware is implemented these days isn't necessarily completely reflected in the policies that exist. So if you're trying to make modern hardware but comply with this policy, there's some issues in between that we're going to talk about that make it very challenging. All right, so in this talk, I'm going to talk about what firmware is, which is probably a good starting point. I'm going to talk about how firmware isn't actually firm, okay? And it isn't usually free either. I'm going to talk a little bit about the Respect Your Freedom certification, which is sort of the best document that we have as far as doing a policy that talks about free firmware. I'm going to talk about the proprietary exceptions that exist within that document, which you may be surprised to know that it allows proprietary software in some cases. I'm going to talk about those cases. I'm going to talk about my experience, and actually I guess my team's experience too, and more my team's experience, attempting to make devices that comply, because again, that's the main standard that we are pointing to, that we have found. And then I'm going to, based on that experience, talk about some suggestions for policy improvements that at least I would personally like to see. And this is more me trying to start a conversation about these issues, because it's not talked about that much. It's talked about a little bit in some circles, but it's not talked about in a wide circle. So I'd like to just sort of start the conversation in the hopes that perhaps we can get new policies out there that would make it easier for people like me to make new hardware. All right, so what is firmware? Well, first, we have hardware, and again, this is all going to be very high level, trying to get very rudimentary kind of explanations, definitions for things, so we're on a level playing field here. So hardware, we're talking things like physical chips, electronics, circuits, stuff that you can touch with your hands. You know, it's not ephemeral. Software, these are instructions, for example, that the CPU will execute. Often, at some point, it's written in 7 different levels of frameworks, and about 27 frameworks down, it becomes assembly code that then the CPU executes. Firmware was called firmware because it sits somewhere between hardware and software. It's not exactly hard, it's not exactly soft, it's firm. And so that was sort of like the fun play on words that all geeks like to do some sort of level of punning in some way, and so this was what we decided back in the day to call firmware. Traditionally, what we're talking about when we say firmware is instructions that are flashed onto discrete chips. And instead of it being instructions that are executed by a central CPU, which is I just was redundant there, but a general purpose CPU, how about that? These instructions are actually executed on some sort of chip that's not the general purpose CPU. Traditionally, we're talking about write once, read only afterwards. So you would flash, you would burn these instructions onto a chip, and then at that point, from that point on, it's basically, in many cases, considered like a circuit. There's no changes, there's no updates, there's no anything. It's a chip with instructions that does a thing. Normally, what firmware would allow you to do is provide some sort of interface between hardware you have on the device and the operating system that you're running, usually through something like a driver. So for example, you might have a network card, and there are chips on that network card that allow you to do networking. And you would have your drivers within your OS would talk to interfaces within the firmware that would then allow you to do things with that hardware. So some examples of things that have firmware would be in older devices, BIOS, for example, or UEFI firmware. Video cards have firmware, network cards, sound cards, hard drives these days have pretty sophisticated firmware. A lot of different things on your computer have firmware. So firmware's not actually really firm. Definitely not these days, and some people would, I've heard some people that work in the industry say it never was, but it's really more like tofu, where you have a couple of flavored varieties of it. So you may have firm, you have semi-firm, you have soft, and this is, so I'm gonna go through sort of my rough definitions of what those categories are about. So for example, firm, I would say write once. So these are chips that you put firmware, the firmware where you put it on a chip and you can't overwrite it, you can't upgrade it. It's on there and it's always going to be on there. I would call that firm firmware. For example, these days what will happen a lot is you will write firmware on a chip and then there's fuses that you can burn that then prevent you from ever changing that firmware. So that's still, I would consider that firm. Then you have semi-firm. So semi-firm firmware is field upgradable in some way, but often it requires you to clip some sort of chip, or clip something onto the chip and then flash it from some secondary device. That's somewhat firm. You do have to like pop open the lid and clip stuff on and have specialized hardware, but you can upgrade it in the field. So it's kind of still like firmware, but it is also kind of like software, right? Because you have instructions that you can change on the fly in the future. And then there's basically like software. And that's really these days most of what you see, which is you can even update these instructions in the OS itself with specialized software in some cases. For example, the BIOS. You can use flash ROM within your OS in many cases on many platforms to update the boot firmware, update the BIOS within the OS itself. So in that case, it's like you're updating any other software package in many ways. So it's a lot like software. Also, in addition to the fact that you may have a chip that has instructions that it is running, there's also load time instructions often, especially these days, or configurations that are loaded at initialization. So you have a lot of hardware, you'll have some sort of base ROM, some sort of base image, and then at initialization time, it's expecting to be fed either sets of instructions, extra code to execute, or initialization code in some sort of configuration, other things, and without that, it won't power on and function. So it expects that these days. Sometimes also in addition to, and it might do that from like another chip on the device, for instance. You might have a different chip that has these instructions that you can then upgrade and it reads it in. Sometimes the OS even provides this. For example, under Linux, there's a whole /lib firmware directory that is full of initialization time firmware that when that hardware is initialized with the driver, these blobs get read and copied over to that firmware and it uses it as instructions or configuration, or it depends on the device, what it does with it. But this happens often even within the OS and these days more often than not. I mean, even the CPU, your general purpose CPU on your computer gets firmware updates, gets microcode updates actually, but I mean, these are instructions that at runtime, that you power on the CPU, it has some sort of base blessed image. When you turn it on and you boot your system, the Linux kernel can provide this, or your BIOS can also provide this. So either your OS or your BIOS can load this microcode into your general purpose CPU and change its configuration on the fly. So I guess if we're going to try to make some sort of distinction about software versus firmware or semi-firmware or whatever you want to call it, I guess one distinction might be that in the case of firmware, you're talking is what chip is executing the code. So for example, if you're talking about instructions that the CPU is executing, maybe that's software. Maybe if you have some sort of secondary chip on the device that's actually executing the code, then it's more likely it's probably firmware. But again, that's the problem with these definitions. There's a lot of fuzz in between. All right, so let's talk about why is this the case? Why isn't firmware firm? Or at least if it used to be firm, why isn't it firm anymore? Well, firmware has bugs, like anything does. And when something has a bug, you could either live with it, like and just let it go, or you can fix it. So if you allow someone to upgrade firmware, instead of it being burned onto a chip where in past cases you might have an issue with a firmware on a chip and the solution was to pop that chip out, plug a new chip in with the updated firmware, and then you're good to go. That's great, but it does require extra like physical hardware on the device to allow you to swap out chips. Two, it's a lot nicer if you can treat it more like software and upgrade things in the field. So these days, people like to do that. It not only allows you to fix bugs, it allows you in some cases to add new features. I remember, back in the day when I was building my own PCs, and we would often want new BIOS updates because when you first got a new motherboard, the BIOS would always have just like a very bare bones limited number of features. And if you wanted to do things like overclock it and do all that stuff, then you often had to wait to get a new BIOS because not only would it fix quirks or bugs, but it also would add extra ways for you to overclock or change all these different settings, right? So it's not strictly bug fixes, it also allows people to ship things sooner essentially and then add the stuff that they should have shipped with it after the fact, like we do with software. Also, hardware has bugs, it turns out, and it's kind of a pain when hardware has bugs because it's sort of locked in place, right? It has to undergo a lot more thorough testing in some cases than software just because it's hard to fix after the fact because it's supposed to be hard. But the thing is that sometimes you can use firmware to fix hardware problems in the field. I mean, that's what we're seeing with a lot of different firmware updates is that if you have a hardware issue, you can often change the behavior of that hardware through a firmware update that can fix that quirk or solve that security issue, for instance, in the case of security issues. For example, this is how Intel responded to the Meltdown Spectre series of bugs that were in I'm not going to dive into all of the history of that, but all that suffice to say that major security bugs on a whole, like many generations of Intel CPUs, well, it's a physical chip that is soldered onto your motherboard in many cases, and not all cases, difficult to replace, definitely difficult to reprogram, but you could, because there's microcode updates that you could apply, and that's how they decided to fix some of these issues was by changing the behavior of the CPU in some ways by having microcode updates. And here's the other thing. If you care about freedom and you care about free software, firmware that you can flash and replace is firmware that you can replace with free firmware in the future. If you have firmware that's burned on a chip, you have to take that chip out and replace it with a new chip. But if you can software update firmware, and we have done this ourselves at Purism, started with something that had proprietary firmware out of the box, as it were. You get sometimes chips that already have proprietary firmware on them so everyone can use them in a certain way. And because they're field upgradable, we've been able to figure out, port free firmware to the platform and then flash it and update it. And of course, it also allows us from that point on to update the firmware ourselves with new improvements. So, but I talk about free firmware, but firmware usually actually isn't free. Most firmware, for the most part, is proprietary code. I mean, there's obviously exceptions like with anything. That's why I use words like most. I guess you would now have to show me that a majority of it isn't. So you'd have to show that no, well, actually, Kyle. I can show you the 51% of firmware by this metric is now free, so you are wrong, and I've corrected you on the internet. Okay, so the thing about firmware though is that it's more hidden than software is. So we in the free software community, we're tangibly touching software in many cases. Some of us are writing the software. We're definitely installing and upgrading that software, so we feel we're more interactive with that software, and so we notice and feel more when that's proprietary versus free. So for many reasons, because of that, free firmware traditionally, at least, has had less of a focus within the free software community. There's been a lot of push on down with proprietary code, but most people are talking about the software you run on your desktop, that kind of thing. There's been less of a focus on firmware. That's starting to change, and we'll talk about why, but it's just less of a focus traditionally. That said, the pain of proprietary firmware is mostly felt in the free software world, because if you're in the proprietary world, you're given proprietary tools that I'm going to run this ThinkPad tool that automatically updates all the stuff that I need to update, and it just sort of grabs all of this different firmware from who knows where that's proprietary and loads it into all of your devices, and my ThinkPad now has all the latest and greatest everything for everything. Of course, if you're on the free software world, then you don't have the proprietary Windows tool, for instance, to update all that firmware. So if you want to update it, you have to figure out, okay, wait, can I use it? Does the tool even exist in Linux? And if it does, what is the magic incantation of arguments to make it actually flash something? You know, and you have to go through all this. So we're mostly feeling the pain of this. But there's been a renewed focus on free firmware recently, and I think there's a few reasons for this. These are at least the reasons I'm going to propose for why people care more about free firmware now than maybe they traditionally have. And of course, there's always been people that have cared about it, but I think more people are thinking about it now. One of the reasons is that we now have 100% free software operating systems available. We've sort of climbed that mountain, as it were. So there are options now where you can pick an OS and have a full desktop environment. It's 100% free software, you know, all the drivers, everything within the kernel, everything else is 100% free software. So once you've achieved that milestone, then you're sort of at the top of the hill and you're looking around like, well, is this the tallest mountain I could climb? You know, and you look at, oh no, there's one over there. Okay, well maybe, what is that? Oh, it's the firmware mountain. Okay, well let's go over and start climbing that mountain, right? And so I think that's one of the reasons is that what's the next challenge? So this is the next challenge that we're going to address. There's also been a renewed interest in general in open hardware. So that, for example, there's a ton of excitement about RISC-V environments and, you know, even beyond that, like ARM environments and other environments where there's more of a potential to have not just like access to the schematics and that sort of thing, but also if you're going to already have access to all the schematics to make the hardware, you also want the ability to make the firmware as well. So more interest in open hardware means more interest in free firmware. Also, another reason is that there's a growing concern about attacks that attack firmware instead of attack software on the operating system. In particular, because firmware is a little bit more hidden, there's a number of concerns that you could embed malicious code within firmware that can persist a device wipe, that could persist, like definitely persist reboots, but persist installing a brand new OS. And this isn't just a hypothetical. There's in the field examples, many examples of this, both from like using the BIOS as a persistent store to reinfect the system after you've reinstalled it. There's also concern in many cases about, well, I can audit all of this code in my operating system and know that it's doing what I expect it to do, but some firmware has very low-level access to the hardware that your system has. It's an ideal place if you wanted to do something really nasty. It would be a great place to have your own code execute, because in many cases you have access not just to the CPU and RAM, but you maybe have access to the video card, you have access to the network devices. So you could see everything that's happening on the system and then broadcast it and share it somewhere. So because of that, some people in the security world are saying, well, gee, it's such a great place to implant malicious stuff. Maybe it would be great if we could audit that. And so people are saying, well, can we audit it? And of course, just because it's proprietary doesn't mean you completely can't audit it, but it just means you have to open up your hex editor and look through all of that stuff. And some people are skilled and can do that. But certainly easier if you had free code and you could trust that and then build it yourself on a trusted environment and reflash it. So I think that's sort of like the final reason that there's been a renewed interest. And again, a lot of our customers, that's one of the reasons that they want us to implement free firmware. So some recent examples of this, Core Boot, which is a free boot firmware replacement that allows you to take whatever, like an AMI or some other BIOS or UEFI firmware on your system, and you can replace it with something that's open source, that is mostly free software. And there's also a couple of examples of embedded controller firmware that you can get. So in the case of Core Boot, for example, like Google has been a big proponent of this, like all the Chromebooks and that sort of thing run Core Boot. So they've done a massive amount of development to maintain Core Boot updated on new platforms. You know, we ship Core Boot, System 76, a lot of other places ship laptops now with Core Boot as their boot firmware, which is great. There's also, then once you climb that mountain, you're looking around like, well, gee, now I have Core Boot, what's next? And like, oh, embedded controller, it turns out, has a lot of really interesting access on your system. It doesn't just anymore control things like your keyboard, but it also has a lot of control over things like battery charging profiles and all kinds of other interesting stuff. And wouldn't that be cool if that were free software? And it turns out it can be. And so a number of companies, System 76 being one, Google as well, and we in Purism as well, are shipping hardware that has free software for the embedded controller, or free software for the embedded controller firmware as well. Even then, they're still blobs, and so we'll talk about a few of those blobs here in a minute. So even with all of this, there's blobs. But let's take a step back and let's talk a little bit about one of the only certifications that we've been able to find and point to when we're trying to get guidance on how to approach firmware in a freedom-respecting way. All right, so Respect Your Freedom certification is the Free Software Foundation's certification for open hardware. Currently, it's one of the few criteria if you want to get information about how should I approach free software and firmware and sort of mesh them together like peanut butter and chocolate. So how do I do that in a way that passes muster? And that's one of the few documents you'll find that gives you some guidance on that. If you were to go to their site, you will find there's a number of certified products. The majority of them are network adapters. Generally speaking, I think most of the network adapters are all sharing a similar chipset, and they're just different implementations of the network adapter. Both there's some like gigabit networking adapters, that sort of thing, and also some Wi-Fi cards. In addition to that, there's also some older model ThinkPads, which we'll get into why they're older model here in a minute. But for example, like X200 and a couple older series, like that sort of era of ThinkPad, a couple of those are on there. There's even some 3D printers that are on there. Generally speaking, when you look at the certified devices, it's generally older hardware, and I would argue, I'm not obviously speaking for them, but I think that the majority of the reason for that in many cases is because of how modern firmware behaves and how difficult it is to get something that uses a new device that has modern firmware to comply with the standard. In addition to a number of other requirements, it requires, if you want to get the certification, all of the product software must be free software. So for example, if you have a Respect Your Freedom certified network card, when you sell that network card and ship it to someone, and if you include software with that card, it must be free software. You can't have like the free CD, remember CDs? You can't have the free CD, wow, I'm definitely dating myself, and then like do they even use CDs? Like I haven't bought a NIC in forever, like standalone by itself. I mean, maybe they do, I don't know. Anyway, not only can you not ship it, but you also can't, you can't inform people that, so say you don't ship a CD because it's 2023, even if you don't ship one, you also can't have the instructions that say, yeah, if you really want this to work really good, what you should really do is go to our website and download this proprietary blob. Like you will lose your certification if you steer users toward proprietary code as well. So that's part of the guidelines. That said, they do allow some proprietary firmware. Audience gasp. But proprietary firmware is allowed in the standard. There's a carve-out for it. And so let's talk about, I did an excerpt because I wanted to practice block quoting, which is really weird. It's justified. I'll just read it to you, though. So, firmware exception. However, there is one exception to having all free software for the device. For secondary embedded processors, the exception applies to software delivered inside auxiliary and low-level processors and FPGAs, within which software installation is not intended after the user obtains the product. I underline that. This can include, for instance, microcode inside a processor, firmware built into an I/O device, or the gate pattern of an FPGA. The software in such secondary processors does not count as product software. So if you have proprietary firmware and it abides by this, then it's allowed. That said, there is an exception to the firmware exception. So let's talk about the firmware exception. There's an explicit exception for the BIOS. All right, so here's what that says. The BIOS of a PC runs on the CPU, not on a separate secondary processor. So this exception does not apply to the BIOS. So if you have a secondary processor, it's basically some other chip that's on a different piece of the hardware, that can have proprietary firmware, and it still can be blessed. But it can't be the BIOS. That can't be the BIOS because the CPU executes that. So essentially, the distinction here is whether the CPU or a secondary processor is running the firmware, is executing the firmware. That's the main distinction where they draw the line. The other line is basically whether the user must install software. So as part of this, you also can't, and they make this clear, when I'm not going to post the whole thing in a slide, but they make it clear that you also can't do something where after the fact, they have this device, and then they need to get proprietary firmware and load it in. Even if it's being executed on the secondary processor, the user shouldn't have to basically be tainted with the taint of proprietary software. So you can't steer the user toward it, and you can't require the user to install it. So because of this rules out basically all modern Intel platforms after the X200 series ThinkPad, basically. because they have Intel Management Engine and modern peripherals. So the Intel Management Engine is a proprietary blob that initializes a lot of hardware on Intel platforms. And after the X200 series, it was, well, before the X200 series, there's a couple of generations before that where it was required, but people have figured out ways to disable it and stop it, and basically overwrite the entire thing, where it wasn't, you could still boot the computer. The people figured out ways to initialize the hardware without the ME. Starting with post X200 now, no Intel platform that has the management engine will execute if it doesn't have at least some of the management engine running. So in previous generations, up to about the 8th generation of Intel, I want to say, we at Purism and other people have found ways to sort of neutralize most of it. So there's a bit you can set that says don't execute, and it's like, okay, I totally won't. And so, but there's also another way, there's something called neutralization where we can overwrite the majority of the management engine's firmware with nothing. Leaving just basically at one point only 4 functions left that was just critically needed to start the hardware itself. That was the state of the art basically up until about the 8th generations. After that, like for example now 10th, 12th, et cetera generations, that no longer works, or at least no one, the original people that worked on that was a group called Positive Technologies. They haven't updated that software yet to do modern things, and we haven't yet had the cycles to do it ourselves. And I'm not aware of anyone else working on the problem. So 10th generation and on, there's no way to at least even override just most of the management engine. You can just ask it nicely to turn off and hope that it does. So anyway, that's the major sticking point these days if you want a Respect Your Freedom certified Intel hardware, is the management engine. So let's talk a little bit about what it would take if you wanted to make a modern Respect Your Freedom device. And again, we're just using that as the standard that we know of, that one of the few that you could point to as guidance. It's difficult. It's very hard. Ask me how I know. It's very difficult. So the software side's relatively easy. All right. Again, we've climbed the mountain of you can have an OS that's 100% free software, and if you're smart about how you pick the hardware that's like network cards and other devices, you can have modern hardware that can run 100% free software on the OS side. So that side's kind of handled. And there's great drivers within Linux kernels and things like that. The firmware is really the biggest sticking point for modern hardware. So let me give you 2 real-life examples. So one is the Librem 14 laptop that we sell at Purism, and the other is the Librem 5 phone. So Librem 14, let me give you an overview of sort of what we're talking about here. So this is a reference, it's a 10th generation Intel laptop. We're using their reference platform, like a lot of people do, because if you want to do everything for 100% from scratch, it's really expensive just to have a custom thing. So reference 10th gen Intel platform. Laptop, it uses, we selected video, Ethernet, and Wi-Fi cards that use free software drivers. So you can use 100%, because our OS is 100% free software. So it's sort of like, if you can install Pure OS on hardware, that's sort of hard mode, because there's no proprietary drivers. So if it runs Pure OS, you could probably load some other distro on it that includes that plus proprietary drivers, and you'll be fine. So anyway, because of that, we pick, so that part's check. All right. Like I said, it runs 100% free software OS, Pure OS, check. That's good. It runs core boot BIOS, which is free software boot firmware, great. Free software, we call it Librem EC, embedded controller firmware. So the embedded controller firmware is free software. The boot firmware is free software. That's all great. But it doesn't qualify for the Respect Your Freedom certification. So let's talk about why. What's missing? There's some blobs, some disgusting blobs. So the following core boot blobs disqualify it, for instance. So core boot is open source software that can include proprietary blobs within it to initialize hardware. Like we said, a lot of hardware requires blobs to initialize it at runtime. So while core boot itself, if you were to look at the core boot code, you would see that there's carve-outs where you can embed in proprietary blobs that it can feed into hardware. So in our case, for our platform, we need to include the Intel FSP blob. So this initializes the RAM, for instance, PCIe, SATA. There's a lot of other pieces of hardware that this particular blob initializes, and those are all pretty important to have a computer work. and then Intel Management Engine, and we already sort of dove into what that is. So those are the two big blobs. Probably the CPU microcode qualifies. Again, so some of this is like a little fuzzy because we know that the microcode is a proprietary blob, right? It is being fed into the main, it is being executed by the main CPU, I guess, so that, by that exception, that would disqualify it, today at least. But it hasn't been explicitly spelled out one way or the other. I'm basically going by the exception to the exception when I say that. In the future, we probably also might be disqualified for our Wi-Fi blob jail, which I'm now going to talk about. So, Wi-Fi blob jail. This is actually cutting edge, like this is new. So this hasn't been, I haven't blogged about this at all or anything yet. So this is like brand new purism stuff that we're talking about here. Blob jail, what is blob jail? It's just a clever, fun name for something. But so let's talk about, give you some background. So from basically the very beginning of us selling laptops, we've sold laptops with the Atheros Wi-Fi card. Why? The Atheros Wi-Fi card is the only blob-free option that exists. All right, if you want to, not only does it run with free software drivers, and it has for a long time, and that's great, it does that and doesn't require, well, you can add firmware, it does in many cases have firmware that you can install, and it supports updating the firmware at runtime initialization with proprietary blobs. It still runs without it, so there's some base firmware that it can run and execute, unlike many other Wi-Fi cards. Other Wi-Fi cards, it's so bare bones before they get that blob that they won't function, all right? So we've forever been using Atheros Wi-Fi cards. Great. A couple problems with it now, years later. Many years later, same card. Well, the card supports the same Wi-Fi specs that it supported when it first came out. Wi-Fi protocols have changed since then. There's a number of new Wi-Fi specs in networks that it doesn't support. So if you're using this card, there's certain Wi-Fi networks that you have to cause them to downgrade into certain modes to function, all right? The other and bigger problem, arguably, because we'll say, well, people are willing to sacrifice some things for freedom. Okay, that's great. We get it. Great. So we'll just keep doing this. Here's the other problem. These are getting harder to find. Not individually, onesie-twosie, maybe not even a dozen at a time, but en masse, like you would want if you're going to make it the base of the Wi-Fi card for your laptop. And most people expect a laptop to talk to a wireless network. I'll tell you, they're getting harder to find. So even a couple of years ago, we started seeing the warning signs of it's getting harder and harder to source this older and older card. And so far, to date, we've been able to supply them. But we also realize at some point the day will come where we won't be able to get enough to satisfy all the incoming orders. And we don't want people to have to like, well, we have to wait for more Atheros cards to show up on eBay or whatever, you know, so we don't want to do that. Instead, we realize we have to start coming up with a backup plan for when that day comes, because even after that day comes, we still want to offer Atheros Wi-Fi cards for people who want that option. So that'll always happen, but we had to have some sort of backup so we can continue shipping laptops that can join a Wi-Fi network. So what we came up with was blob jail. Oh, finally, the other thing is you might say, well, why don't you just create a brand new free software loving, free firmware Wi-Fi card? That'd be great for the community and all that stuff. Well, there's a couple reasons. One, it's incredibly expensive to do that. It takes a lot of resources just to have the one Wi-Fi card, so that's super expensive. The other thing is Wi-Fi is very patent encumbered. So, and that's one of the other reasons why you see a lot of issues in this world is that all of these new Wi-Fi standards have all kinds of patents associated with them that various entities own. And that's a very challenging framework to navigate. It's a lot easier if you can get something that's already, where someone's already gone through that and is using some sort of reference platform. So brand new card is, at least for now, out of the game. So the backup plan is we'll use Intel Wi-Fi just because everything else is Intel. Pick one that doesn't have any sort of weird integration into like remote management or any of that stuff that might, in theory, if you installed an alternative management engine, be able to do that. Pick like a very bare bones but relatively modern Intel Wi-Fi card that's widely supported, you can widely available, things like that. And what the plan is to it requires blobs to initialize, like pretty much every other than Atheros Wi-Fi card. But the idea is to put these blobs in what we're calling blob jail in the boot firmware. And again, our core boot firmware already has 2, 3, blobs in it. So it already has the Intel FSP, it already has the Intel management engine, and it has a microcode, Intel microcode for security updates. So now we're talking about an extra blob jail, a blob jail for this extra firmware. So what would happen? So when you boot, our boot firmware, we're using, this will be implemented with Pure Boot, which is our tamper-evident boot firmware that's a runtime within Core Boot. It already has mechanisms, so we validate other things that for signatures. We make sure that things haven't been tampered with. We do the same thing for the blob. So in this case, we say, is this blob the same blob that we blessed before, or did someone replace this with something maybe malicious? So that's step one. Can we trust, even though we can't see inside of it because it's proprietary, do we at least trust that it hasn't been tampered with? And so once it passes that step, then when we initialize the kernel and boot the kernel, we pass this blob along to the kernel, so it has it as firmware. So then when the kernel initializes the Wi-Fi hardware, it can pass this blob along to it. Now the hardware's running, and then from that point on, it's functioning. With this method, the operating system can still be 100% free software. Free software drivers, all of that's free software. The CPU doesn't execute a blob, but what it does do is it copies a file. So it must then, I guess, take this file, put it into RAM, and then pass it along to the kernel. All right? So it does copy a file, but it doesn't execute any code. So that's sort of like our solution. And the user, it's transparent to the user. Like if you're a user using the system, you don't know that you're not having to install anything. There's no proprietary firmware that you're touching after the fact. It's transparent to you. You can install a free software OS and it runs. So that's one example of our attempt and failure so far to have something kind of comply and the reasons why. So let's talk about the Librem 5, which is an even more promising way to do this because, so what is it? It's an in-house phone that we've made that's uses ARM as its platform. And it's a smartphone that runs Linux. We designed it from the beginning using the Respect Your Freedom certification as like the standards document. We're like, okay, we're going to comply with the standard. Can we make a modern smartphone that complies with the standard? So we use that as our standards document. It runs the same OS. It's not running Android or iOS, so it's running free software. It's running the same free software as our laptop, all right, pure OS. Couple things of note, the modem and the Wi-Fi Bluetooth cards are on independent, discrete N.2 cards that are removable and replaceable. All right, so that's another way that we can kind of isolate things. We chose the hardware because we're designing this from scratch. We picked it specifically for its optimum FOSS support. Now, that doesn't mean everything's supported, but for example, if you're looking around at what ARM chips are on the market, what you will notice is if you've ever used ARM computers, you will notice that often a kernel is sort of locked in time. It's like a snapshot because often there are proprietary hardware drivers that are being paired with that kernel and locked into place. And unless the vendor who created that kernel and those proprietary drivers keeps it up to date, you're ending up, at first you get a brand new piece of hardware and like, oh, this is great, it's running a relatively recent kernel, and then years go on and maybe the OS gets updates, but you still have to run that kernel from like 5 years ago. And eventually it's kind of like unsupported. This is a problem even with Android devices, right? You'll have an Android version and the kernel itself is kind of locked in place because it has proprietary hardware. So we also even selected the hardware can we get hardware that we feel good about? That we could mainline everything? So all the drivers that the CPU would use, for instance, are all free software. So there's no need to have a blob that's locked in time. This obviously required a lot of kernel work. It's still ongoing. The kernel work is done in terms of like support for the hardware, although there's always improvements. Right now, the work is basically mainlining all of it. And so every month, we're taking more of the code that we had to generate to support this particular ARM chip in the Linux kernel and mainlining it into the main Linux kernel, ultimately so that it has infinite lifespan, even past purism at some point. It'll still be supported and supportable. It does have blobs. I'm going to get into those. But some of the blobs are actually free software. So when we could and when we can, we pick firmware that's free software. But not all of it is. So it has closed blobs. But again, we tried to implement these blobs in a way that is Respect Your Freedoms compliant. So what does that look like? So let's talk about these blobs. So the touchscreen and the modem both have what I would call soft firmware by my previous definition, all right? So what I mean is it has firmware that's proprietary, that's on the device, that you can update from within the OS using specialized software, but you don't need to, you can boot the device and you don't need to pass any extra blobs to it to turn on the device. It has something burned onto it, so the modem and the touchscreen both are like that. So they could be field upgradable in theory if you had the software and you had the blob, you could upgrade them, but the user typically wouldn't, all right, because it already comes configured. Other firmware also requires some sort of runtime loading because that's the way that modern hardware often is. And so in some cases, what we had to do, again, because we're sort of trying to comply with this, with also the way that modern firmware is, we created ROM storage in some cases, like outside of the CPU, but storage on the hardware that would store this initialization blob. And then at initialization, we would capture it from there instead of like local disk storage or something, capture it from this flash chip, and then pass it over to the hardware so it could initialize. All right, so we went to extra steps to do that. So some examples of this would be the USB-C chip. So, you know, every device has a phone you'd want to plug into USB-C. That chip requires firmware. That requires initialization code. DDR training, so training the RAM itself when you requires that, and the display port all require a blob. Also, Wi-Fi is modular. The original Wi-Fi card that we used didn't necessarily require a blob for initialization, at least not one that was present to the OS. The new Wi-Fi card that supports the modern standards, a couple different reasons. I wrote a whole blog post about why we made a transition to a new Wi-Fi card, but the fact that it's modular means that we could. It needs blob jail, so we implemented a form of blob jail within the boot firmware of the Librem 5 as well to support this new Sparkland Wi-Fi card. The important thing is none of this taints the user. So the user gets a device that has all the firmware flashed and ready to go. There's blobs in there, but they're not touching them at all. They're not downloading anything. They're not installing anything proprietary. It's all 100% free software as far as what they touch. But even though we have this compliant thing, it's not necessarily ideal. There's issues in having like all the steps we had to go through to get this to be like this. So to me, there's room for improvement. So one of the things I'd like to say is the policy needs to reflect the current state of hardware, the way that people develop hardware today that uses firmware. Ideally, we would have some policy document out there that cares about free software and cares about freedom, but that also reflects the state of the art as far as how hardware is being developed these days. So for example, the current policy, let me give you some examples. If something that's not the CPU copies a blob from a ROM, it's totally fine, no problem. If the CPU copies the blob from flash storage, maybe that's okay, maybe not sure. If the CPU copies a blob from a disk, it's probably not okay. Not sure, but I feel safer saying it's probably not okay, but maybe it is okay. If the CPU executes a blob from disk, that's definitely not okay. So don't do that. That's clear. All right, but see, you can see the ambiguity here. So what does this mean? What we had to do in many cases is we had to create an extra hoop where we had a ROM and we put initialization code there and then went through extra hoops so that the chip could be initialized from something that wasn't local storage or something. It was something on the device itself. If you wanted to create, for example, we were talking about, well, what if we did create our own Wi-Fi card, but what basically we did was we figured out a way to take an existing Wi-Fi platform, take that blob, and then put that blob on a ROM, and then when it was initialized, there would be something on the chip that would then take that ROM and feed it in initialization time so it's transparent to the OS. And we're like, yeah, that would probably work, but it's a distinction without a difference. You know, like you're going through these extra hoops to do this thing, but it's not really any different from any other way that we now are saying is not necessarily okay to do. So you're going through all these extra steps, but you know, it's like, look at this curtain, and then over here, you're still like touching blobs all day long, right? So it's blobs either way, but currently we don't have a good way to address this or talk about it even, because it's very binary. You're either, like evil and proprietary, or you're 100% pure, and no proprietary bits, or except for the exception, right? When it does this sleight of hand, right? So it's a distinction without a difference. This need for at runtime for you to pass some sort of blob to hardware that has either firmware or instructions or some sort of runtime config or something like that is unlikely to change. You can think of all the different benefits if you're developing hardware of having that system in place where you know that at runtime they're going to get the latest and greatest set of instructions with patches and bug fixes and whatever else. And so all I need to do is create the safest possible ROM on the hardware that just knows that can, without any bugs, load in this blob. You can see why that would be appealing to someone developing hardware because they can have a very trusted thing that doesn't change, and they know that the thing that could have bugs in it, they can just replace that with something else in the field very easily. So it's very appealing. So because of that, I think it's unlikely for people to say, you know what, let's go back to having discrete chips that you can never overwrite. I don't think that's going to happen. So as a result, we need to address this reality. So to me, I think in particular, we need to have an exception that calls out specifically when a blob is copied, but not executed. I can understand having concern about, for example, a general CPU maybe executing proprietary code. I think I think it should be treated differently than having a file that's proprietary, it's a blob, copied but not executed. Because it's, again, very similar to the hoops that we jumped through to have a ROM with the thing that got copied to a secondary CPU. I also would like to see an exception for CPU security microcode updates. As we see, as CPUs get more and more complex, and the software that runs them, or firmware, if you want to call it that, or microcode, is more complex, that there's going to be security bugs. And after Spectre Meltdown, you know that everybody that was in that field is just like, oh, I can also get like a keynote, a black hat, if I can come up with some new way to do whatever. And so everyone's digging in and trying to figure out new ways to exploit things. And even with the new microcode updates, can we get around that in some other way? And there's been some examples of that. So I think that's going to be ongoing. I think it's useful for your CPU, the most important, arguably, chip on your computer, to have recent security updates. So I would like this, and it's acknowledged that it's running proprietary code already, right? So I would like to see, if it's already running proprietary code and has a microcode update, I would like there to be some sort of exception that allows you to update your CPU so it's not out of date and insecure. Ideally, what I'd like to see is instead of some sort of binary system where you're blessed or you're evil, it would be great that there were like levels or a sliding scale or a rating or something like that, because what it allows you to do is to increment towards success, which is something that we've been doing from the beginning, for example. You know, like if we were going to wait until we had a laptop that ran 100% free software OS, 100% free firmware, we would still not be selling laptops, you know, and we wouldn't therefore have an ability to incrementally improve the hardware and identify blobs that we could then replace. So for example, the very first Librem laptops did not have, it had a proprietary boot firmware, for instance. It was only after, but at the time we said, this is a problem, and after we ship, we're going to be freeing that and then ship an update so that you can replace this proprietary BIOS firmware with free, which we did. Then later with the Librem 14, then we look around, again, you're at the top of this mountain, you look around, okay, what's next? In the case of core boot, there's been blobs within core boot that we've been able to eliminate. Not just our effort, it's simply that the core boot community also, in general, has been able to take away, for example, Intel video BIOS was something that traditionally an extra blob you had to add, and now there's an implementation within core boot where you don't need it anymore. So the ability for us to have a sliding scale of which things are, this is at least freer than this, it would encourage people to put the effort to at least make things better without effort being completely dismissed because you weren't able to go 100% all the way. That's I guess what I'm saying. All right, so conclusion. Oh, we're doing all right on time. Oh wow, we're actually doing pretty good on time. All right, so if all of your software is free, then that puts the firmware sort of in the spotlight. You're like, well, now that's not free. Firmware isn't firm. We've established that it's more like tofu. Soft firmware isn't completely bad, though. I mean, there's a lot of good things about it. In particular, if you want to replace proprietary firmware with free firmware, you need it to be soft. There are many people out there trying to do the right thing, and there's a lot of effort being put into freeing firmware as we can and doing things to improve the openness of hardware, which is great, and we're going to see more and more of that, I think. Hardware's hard. Everyone says that, and anyone who works in hardware will tell you that, and they know what they're talking about. Open hardware is harder, I would say. And we need updated policy guidance. So those of us who are trying to do this hard work, it would be very beneficial to have policy out there that we could point to and look to and attempt to abide by that reflects the modern state of what hardware's like. So those of us who want to do the right thing can continue to do the right thing with proper guidance. And finally, I would like whatever that guidance be to allow incremental improvements instead of an all or nothing kind of thing. All right, so open it up for questions. Here's some links to the talk, so you can see all that. I think we have a microphone. Yeah, you have I thought someone was going to bring around a microphone, I think. But yeah, let's open it up for questions. I have a question here down in front.
Sean has a question.
Oh, Sean has a question.
Well, let me try my full volume. Okay, go for it.
Wait, I think we're going to have a microphone, right? Yeah, so, all right, so our friend Sean couldn't make it to scale, but we have brought the second best thing, which is a giant form of his head that we're taking the talks. And now he gets to ask a lot of questions. Before he asks, I just want to say, and I don't want Sean to get a big head about it, but I just want to say that he's like one of the nicest people. And if you've never met Sean, like, please try to meet him at something. He's just awesome. Anyway, go ahead.
Okay, go for it now.
Okay, I didn't hear what you just said about my giant head, so, but thank you for bringing the stick and the glue, Kyle. First of all, I appreciate that you brought the stick and the glue for my head. My question is, so the idea of a rational policy that could allow for certification or tiered versions of the same is incredible, but you mentioned like the possible need of additional chips and migrating or moving blobs during the boot process. And I'll be honest, as a Linux person, I'm still reeling from BIOS/UEFI/secure boot, etc. Will these compliance hoops, awesomeness notwithstanding, move us further away from some semblance of standardization? Will it just mean like one more thing to learn in addition to everything else? Or will these sorts of things be able to be built into one of the existing 12 standards? Like, is the idea to use Core Boot or LibreBoot or Tiano, EDK, or will there need to be like a new clean blobby boot that hardware, firmware, manufacturing places will need to adopt?
All right, great. So let me summarize the question for everyone in the audience. So thank you for the question first, Sean. Thank you for coming. Basically what Sean was asking is like, so there's a lot of complexity when you're talking about how firmware interacts. I mean, this talk kind of establishes a lot of that. And there's already so many different compliance regimes outside of open firmware. And so sort of the question is, would adding an extra policy on top of that cause less standardization? Would it cause more fragmentation of standards if we went that route? Or otherwise, how can you avoid that? I'm kind of summarizing a lot of this. So my answer to that, I think, would be one of the issues we have now is the lack of there's only basically one kind of standard out there if you want to do this kind of work, which is respect your freedom certification. And so I think that's more of the issue, is that there's just this one, and unfortunately it doesn't account for a lot of the modern state of hardware. So it means that if you're a company trying to do something like this, you're kind of like you're not flying completely blind. You have some set of guidance, but not enough to get all the way there. So you have to come up with your own rules, essentially, internal rules. So to me, my answer would be having some sort of agreed upon standard within people that are in the industry that already understand firmware, who also all of them share the same values as far as free software goes. If we have some sort of agreement on a policy that we can all point to, then I think it would cause more, in the same sort of way, for example, that iFixit, for example. If you're looking at repairability, one of the things that now all the entire industry said, okay, well, instead of us coming up with our thing and you coming up with your thing, we'll all just sort of comply with the iFixit standard. And that's the one that we will point to. So instead of them all trying to come up with a repairability standard, they could coalesce on one. And I would like to see something like that for that again, a modern approach, perhaps very similar to respect your freedom, but that accounts for the modern state of firmware. And so I think if we had that, it wouldn't cause fragmentation, but instead it would allow people who want to do this work to have something they can point to and a standard they can point to try to comply with it. All right, that was a super long answer. Any other questions? Technical question? All right, I'll try, let me try.
You mentioned that using ARM as a reference architecture, but then also later on you mentioned the Intel micro management.
Uh-huh.
Does the ARM have the same kind of thing, or how do those get conflated?
Sure, yeah, so the question was, I talked about Intel platforms, I also talked about ARM platforms, and we talked about some issues with the management engine on Intel platforms, but does ARM have a similar thing? The answer is, it depends. So for example, AMD definitely has a similar thing. They have their own version of a management engine that doesn't have like a way to disable or anything like that necessarily, to date at least. But the security update part. So ARM, I believe, has ways to update microcode and that sort of thing, but it doesn't necessarily have. I don't know all the details about it. Yeah, I don't know all the details about what, but I also know the other thing is like, it depends is a very strong phrase in the ARM world because it really depends on which things off the shelf you pull in and put into your chip. Yeah. Any other questions? Yes.
I had a question, updating firmware. Can they try to update like system on a chip firmware?
What do you mean? So you're asking, have they tried to update system on chip firmware? It's like which they? What do you mean?
Well, just the industry.
Industry? I mean, in general, yeah. Most firmware, there's much of it. There are ways to update it, either through a hardware flashing way where you clip something, or within the OS itself. There's a lot of times, yeah. So there's a lot of times that firmware on those chips you can update them live within the OS.
I mean, like when they update them on a system on a chip firmware, do they have to update the whole chip, or can they update parts of the firmware?
Oh, I see. So I don't know all the details. So the question was, if you're updating firmware on system on chip, is it like all or nothing, or are there components? I think it probably depends. Again, I'm not an expert in this. I've seen that in many cases, when you have a system on a chip, there's still like individual storage areas, I guess, where some of this will go. And I think that in some cases, you can update firmware individually separate from having like an all-encompassing blob. And I got some nods from people that actually know, so I'm going to go with that. All right. So any other questions? All right, well, one from someone who knows.
So if we did have like a revised RYF for adding more exceptions, would it be to satisfy the original goal of having a more open full platform, have an additional specification for, that's not for the full product, but for specifically the platform itself, to have no proprietary blocks as a separate specification to have a more broad, like you can cover both of it. There's nothing proprietary.
I got most of that. So let me see if I can you actually bring in the microphone? I think that would be a lot better, because I could hear like the first row was great, and even the second row I could kind of hear, but now we're getting back to the back, and I can't hear as well.
So your desired state would be a revised RYF to have more exceptions to cover these cases where you're having to jump through hardware hoops to go through the exceptions that were originally intended. Would it be, so then if that were the state of affairs, would there be a strong desire to have an additional specification for platform level, not product level, for no proprietary blobs at all that could be separately met?
I see. So yeah, so actually I guess I don't have to repeat the question because it was in a microphone, but so my answer would be that's why I'm really like strongly advocating having levels to this. So for example, the top level would be the ultimate desired state that actually goes beyond RIF, right? Because RIF has all these carve-outs and all these exceptions, right? So you would have some magical platform in the future that's 100% blob-free. The specifications are completely open. You could go in your garage with some sand and really good lasers and make it yourself and program it yourself, right? And then all the firmware's free and everything's free, and that's like sort of like the pinnacle. So that's the thing that we ultimately, so that'd be like level 10, right? And then below that, it would be like, okay, well, that's not achievable today, but it may never be achievable if that's the only thing you had, right? So the idea is like levels below that where, for example, RYF as it stands today with some modifications would be at some level there, but then there would be things that were maybe less free in certain aspects because, for example, they allow CPU microcode updates, or things that are more free because, not just because of what they disallow, but because there's certain requirements beyond that, like maybe that at some point, maybe the CPU microcode needs to be free, or, so which might be possible with a RISC-V environment, perhaps. But yeah, so that's why I want levels, is because I think if you only have either like that pinnacle that will never exist in nature, or maybe one day will, and you have nothing, then it's harder to even get there. So if you have sort of milestones along the way that you can reach, then you're like, okay, well, at least I got this far, and I can draw, like, for example, the 100% free OS. Like, there was a time where that was pretty challenging with modern stuff, right? But we're there now, and so having those levels, I think, so anyway, the answer is, I think having levels would get us there. And so you have stricter and stricter. Okay, any other questions? We're kind of running, yeah.
In this process, as we evolve to that level that we think we're going to achieve at some point.
All right, so.
Yeah, right. At what level are we at right now that you see ourselves to be at that next level of the mountain where we're looking around going, okay, now what are we going to do?
Sure. Yeah, so what level are we at now? Well, one, I wish we had levels. If we had levels, I could answer that. I could be like, well, we're at certification level alpha 4 or whatever, So that's the problem because there's no levels of this, it's sort of like there's only really one standard right now, and it's kind of an all or nothing sort of thing with some exceptions. And so it's hard to say, I can't answer completely. What I would say was the closest that we've gotten would be the Librem 5, right? Because we had such control over it, we weren't basing it off an existing reference platform, we were doing it all from scratch. Massive undertaking, incredibly difficult. And even then, you've seen the exceptions we had to make. Why? Because each of those are the little milestones on the mountain. We're like, well, are we going to really write touchscreen firmware from scratch right now? Like, is that a good use of our resources compared to all the other things we could be doing? Not yet, But if that was the only thing left, then we're like, well, why not? I mean, even let's do it so we could be 100%, But yeah. Any other questions? Otherwise, yeah. One more question.
Yeah, so sort of iterating on that topic again, would it be preferable to, instead of having levels, have a disjoint set that is just at the lower firmware level that could be separately strived for independently on other parties who don't care as much about the fully open source platform or total product, but rather so that's a vendor could theoretically strive towards a SOC that is no requirement for binary blobs without the total ecosystem meeting the more strict total level of everything open source.
I think at least what would be beneficial to me would be having something similar to what we see now with respect to freedom, which is if you would like to make hardware, like you would like to create software that is blessed as being free software, if you would like to create hardware that enables similar freedoms, respects certain similar freedoms, here's the guidelines. And then the more that you do, the more you're respecting freedom, the freer the thing is. And like I said, that's why the levels are important. I think at least that would be more beneficial to me. Is essentially like that. So anyway, yeah. So that's what I would like. Okay. All right. Well, thank you everyone for coming to the talk. And if I'll be down, we can talk.